Bismillahirrahmanirrahim. Let's talk about the biodegradation of pentachlorophenol. Again, it is one of the many compounds which are hard to degrade in the environment and they can cause toxicity as well. Now, it has been used as a wood preservant and is much widely used in the entire globe. It is toxic and listed as the primary pollutant, priority pollutant by the US EPA, Environmental Protection Agency, because of its harmful effect on different life forms. And as it is widely used, it has contaminated so many different environments, both soil and sediments and water bodies as well. Now, if you talk about how much percentage of PCB is there in a typical solution, normally it is 85 to 90% PCB there, along with some other compounds which are normally generated by the condensation of two or more molecules of PCB. तो उसी को कंडेंस करके जो बाकी जो है कंपाउंड वो जनरेट होते हैं, लेकिन जो एक्चुअल कंसंट्रेशन है पीसीबी की किसी भी टेक्निकल ग्रेड सोल्यूशन में वो 85 to 90% है. Now, basically it contains phenol, and phenol is a very weak acid. The pKa value is 9.82. Therefore, it usually does not ionize at neutral pH. However, it is attached with the chlorine, and chlorine is basically electron withdrawing group. So ये electron withdrawing group है, इसकी वजह से the hydroxyl group present on the chlorinated phenols, that becomes a stronger acid due to the presence of chlorine. So you can see easily that trichlorophenol has a pKa value of 6.13 and pentachlorophenol has a pKa value of 4.75. So the more the chloride atoms are there on the phenol group, the more acidic it becomes. Thus, phenols with 3 or more chlorine atoms on the molecule are much more acidic and can be ionized at neutral pH. And as these can be ionizable, the phenols are quite soluble in water, and therefore these compounds can find their way to different water bodies and can contaminate them. In addition to this, it is very interesting that the PCB, they also have very high octanol water partition coefficient as well. And हमने इसको previous lessons में discuss किया था कि जितना ज़्यादा ये high होगा coefficient, इसका मतलब है कि उतना ज़्यादा ये compound जो है ये soluble है organic content में, उस पर solve कर सकता है, उस पर attach कर सकता है, and can partition quite strongly in the organic content present in the soil. So therefore, due to these abilities, the PCB pentachlorophenol, they can not only present in soil, but they can also find their way in the water as well. So that's why these can be found in so many different variety of environments where they are contaminating the soil as well as water. Again, now the partitioning is pH dependent as well. These compounds can be degraded both aerobically and anaerobically. Microorganisms are present which can degrade these compounds in under both aerobic and anaerobic conditions. Depends on how much complex the structure is, and depends on the availability of the environmental conditions, the nutrients, the electron donor receptors, and the required microbes. Now, if you talk about aerobic degradation, it normally occurs more readily with less chlorinated compounds. हमने पहले भी जिक्र किया था, बाकी जो compounds है जिनमें क्लोरीन होती हैं या हेलोजेंस होते हैं, उनमें हमने देखा कि जितने कम क्लोरीन एटम्स होंगे उतना रेडली वो कंपाउंड जो है वो बायोडिग्रेडेबल होगा अंडर एरोबिक कंडीशंस. लेकिन जितने ज़्यादा उसमें क्लोराइड एटम्स बढ़ते जाएंगे उतना वो रिकास्टिनेट होता जाएगा अंडर एरोबिक कंडीशंस, तो उतना ज़्यादा उसकी जो डिग्रेडेशन है वो एनारोबिक होगी. फिर now aerobic microbial degradation processes mostly involve the substitution of hydroxyl with the chloride atom ion. And the anaerobic process की अगर हम बात करें तो उसमें जो ज़्यादातर यूज़ होता है वो reductive dehalogenation है. अगेन ऑलमोस्ट द सेम प्रोसेस जो कि हम बाकी सिमिलर कंपाउंड्स के लिए भी पढ़ते आए हैं. अगर जब भी इसको माइक्रोब्स डिग्रेड करते हैं तो इसको मोस्टली दोज माइक्रोब्स कैन यूज इट एज अ प्राइमरी सबस्ट्रेट और वहाँ से उसको एनर्जी और कार्बन हासिल कर सकते हैं इन ऑर्डर टू ग्रो. लेकिन बहुत सारे इसको को-मेटाबोलाइज भी करते हैं. And the process of co-metabolism is almost the same as with the other such related compounds, and we need donors and acceptors as well. Different organisms appear to have different pathways for the degradation of this compound. Depends उनमें कौन से enzymatic processes हैं उसके मुताबिक different pathways operate होंगे. जिसकी अगर हम एनारोबिक बायोडिग्रेडेशन की बात करें तो वो एक लिहाज से ज़्यादा क्रिटिकल है क्योंकि दिस पेंटाक्लोरोफिनॉल कैन फाइंड इट्स वे टू डिफरेंट वाटर बॉडीज ग्राउंड वाटर्स एज वेल जहाँ पे ज़्यादातर एनारोबिक कंडीशन प्रिवेल करती हैं. तो वहाँ पे जो है इसकी फिर एनारोबिक माइक्रोब्स के थ्रू इसकी डिग्रेडेशन होगी. जब ये एनारोबिक प्रोसेस में जाता है डिग्रेडेशन के तो दिस पीसीबी नॉर्मली एक्ट्स एज इलेक्ट्रॉन एक्सेप्टर और इसकी रिडक्शन होगी. रिडक्टिव डिहाइड्रेशन का प्रोसेस है जो कि हम पहले भी पढ़ते आए हैं. ऑलमोस्ट द सेम मैनर एज फॉर अदर एलिफेटिक एंड एरोमेटिक हाइड्रोकार्बन्स. अगर ये इसने एज इलेक्ट्रॉन डोनर इलेक्ट्रॉन एक्सेप्टर के तौर पे एक्ट करना है तो ऑब्वियसली देयर शुड बी सम इलेक्ट्रॉन डोनर एज वेल सच एज एसिटेट एनी ऑर्गेनिक कंपाउंड और मोलेकुलर हाइड्रोजन. Different types of dechlorination processes can happen. Ortho is normally happens most readily, followed by para and meta dechlorination. So again, different इसके preferences हैं कि most readily dechlorination कौन सी होगी. Complete anaerobic dehydrogenation to phenol is also possible. Depends कौन सी condition वहाँ prevail कर रही है environment में, कौन से microbes हैं, कितने उनके पास reducing power है और nutrients हैं, उसके मुताबिक complete up to phenol dehydrogenation is possible, and phenol is eventually biodegraded again under anaerobic conditions. So eventually complete mineralization can be achieved provided if the correct parameters, correct environmental conditions, reducing power, nutrients and the required microbes are present. This was about the biodegradation of pentachlorophenol. I will see you in next lessons.